Hello everyone, I am Smith Maheshwari, working as assistant professor in ABES Engineering College. Today I am delivering a lecture of frequently asked question in unit number 2 of AC system of subject fundamental of electrical engineering. So here this unit is into three parts. First, we discussed the AC fundamentals, then single phase AC system and three phase AC system. In AC fundamental, first of all, we discussed some waveform representation, sinusoidal waveform, half wave rectification, full wave rectification, triangular wave, square wave. These all are alternating waveforms. Then we derived the RMS values, mean values, or form factor and peak factor. These are the comparison sheets of these waveforms and its corresponding values. Then we discuss the coordinate system, how to represent our AC quantities, either voltage and current. So there are two types of coordinate system, rectangular and polar coordinates. So here the on the x-axis there is r cos theta, and on the y-axis that is r sin theta. So the combination of these two quantities when representing like x plus iota y, that system is called rectangular coordinates. And when this the position of any p with respect to origin is r with an angle theta, and then this r angle theta is called polar form. Here there is a example 12 angle 50 degree is in polar form. When we are converting to the rectangular, it is 12 cos 50 plus j 12 sin 50. That would be 7.71 plus j 9.19. So this is the rectangular waveform, rectangular form. Now, if we are talking about the topics which are discussed in the unit, first we discussed uh, AC excitation on R, purely resistance, purely inductance, purely capacitance, then the combinations of RL, RC, and RLC. Then we discuss series circuits and parallel circuits, series resonance, parallel resonance, and the resonating curve, resonating frequency, quality factor, form factor, uh, and bandwidth. Dynamic impedance in the parallel resonance. So one is the acceptor circuit, that is series resonance, and parallel resonance are the rejector circuit. After that, we discuss these problems of this unit, then the resultant voltage of these four waveforms, and the similar questions for RL combination, the power consumed by coil, consuming 150 watt when 30 volt DC is applied, and when the 54 watt consuming on 30 volt AC supply, then determine the resistance and reactance. So this is the problem of finding the circuit nature and elements. In the question number 2, there are two Z1, Z2. This is the parallel series parallel circuit questions, and we are finding the resistance inserted in the Z2 in order to change the power factor. So this is the power factor improvement problem. In question number 4, again, this is the question of power factor improvement when any capacitance is needed to be in series or in parallel to in order to change power factor at the desired value. At the starting, this is 0.6, and in the later on, when we are improving, that is 0.8 lagging. In parallel questions, this is the uh, our part of this is the question of series parallel circuit. So we are finding the current, total impedance, power losses, and the power factor. And next question, we this is the resonance question, and these are the parts finding frequency, current, power factor, voltage across is the resistance, inductance, and capacitance, half power frequencies, bandwidth, and quality factor. So this is the numerical of series resonance. And in parallel resonance, this is the circuit having resistance and inductance in parallel with the capacitance. So we are finding the resonant frequency, dynamic impedance, bandwidth, and quality factor. In the last part of this unit, this is the three-phase AC system, and there are two types of connections, star and delta. So this is the circuit given and applying the 230 volt supply. So we are finding the line current, line power, phase power, power factor, three-phase complex power of both connection star and delta connection. So in such a way, we are developing first the derivations and the relationship, then discuss the numericals of each topics which is covered in AC system. So these are the references. This is our disclaimer, and this is our thank you so much.